One and all. I, Professor Radha Shirbate, extend a warm welcome to all in third EAI International Conference on Intelligence System and Machine Learning, organized by GH Raisoni College of Engineering and Management, Pune, India, in association with the European Alliance of Innovation and Extension. On behalf of GH Raisoni Group of Institutions and GH Raisoni College of Engineering and Management, Pune, AI and EAI Department, I welcome our today's keynote speaker, Dr. Neha Sharma. She has more than 24 years of experience and recently working with Tata Consultancy Services and in the Founder Secretary Society of Data Science. Prior to this, she has worked as a director of Premier Institute of Pune that runs post-graduation courses like MCA and MBA. She is an alumni of Premier College of Engineering and Technology, Bhubaneswar, and completed her PhD from prestigious Indian Institute of Technology, Dhandhad. She is a senior IEEE member, ICM, distinguished speaker, and was Secretary IEEE Pune section for the year 2021. She is an excellent academician and has organized several national and international conferences and published several research papers. She is a recipient of Best PhD Thesis Award and Best Paper Presenter at International Conference Award at national level. Recently, she has received a Golden Book Award 2023 for the book title Towards Net Zero Target Usage of Data Science and for Long-Term Sustainable Pathways. She is a well-known figure among the IT sector and well sought over all her sound knowledge and professional skills. Neha Sharma was instrumental in integrating teaching with the current needs for the industry and steering students toward their bright future. We are really thankful for her for taking time out of her busy schedule to attend this event. So, without wasting much time of her, I request Dr. Neha Sharma to enlighten with the audience with the prestigious guidance on the topic data to data product. Before that, I request Dr. Rashna Sabal ma'am to please felicitate Dr. Neha ma'am.
Am I audible? So first of all, let me thank my friend Dr. Mohanty for inviting me for this conference. Thank you, madam, for inviting me, and thanks to the Raisoni group for organizing this conference where we get chance to interact with so many researchers, so many professionals across globe, right? So the topic which I have chosen is data to data product. And this is a very important topic, and also it is very important for all of us to understand when we talk about data science, where this data product resides. What is data product? Is everything data product, or there is something which is very special and it is called data? So we will see all of that. But before I come to data product part, it is very essential to understand data science pipeline. So that because the data science pipeline itself forms your data product, right? So we will go through data science pipeline and then probably data, right? Is the screen visible to everyone? Because it is important. Couple of things which I will be showing will make lots of sense, right? So I have intentionally kept this presentation very simple. Most of you must be knowing most of the things. What I have tried to do is to just put everything together for the easy consumption of everyone, right? Shall we start? And this is all done. We skip this. So very important part, which is very close to my heart, is the formation of Society of Data Science in the year 2018. And we have been, the idea is to bring all of people who are interested in the world of data science to come together. And we have students also, school students also, right? Till like advanced and very esteemed people who have been working in the area for 50 years. Right? So we have the entire gamut in the company. We'll start with a simple thing which comes to our mind. We use it maybe 100 times in a day, data science. And as you know, this is a combination of two words, right? Data and science. Now, data is something which you feel is important and you want to store it. for future reference, right? There's no confusion, right? And science is a vertical which is focused on study of structure and behavior of anything. If you study the structure and behavior of, say, Earth object, it becomes Earth science. If you study structure and behavior of space object, it becomes space science, so on and so forth, right? Likewise, if you study the structure and behavior of data, it becomes data science, right? So you have to understand what are you essentially going to do. You are trying to study your data, right? Study your data, study the behavior of your data, and what else you can do from that, right? So the entire faculty revolves around this prime objective, which is essential for us to know. Now, before I get into that, Acha, how much time do I have? It is already 10:30.
ఇక్కడ జస్ట్ చాలు.
So I will be really quick. Okay. So before I start, there was a survey done in 2006, and this survey was to find out top 10 leading companies of the world, right? And the result of the survey had 5 energy companies and 1 IT company. Can you just guess which IT company that would be in 2006? The top 10 leading Infosys. It was Microsoft, right? So 2006, only one company in the list of top 10 companies, that was Microsoft. 2016, again the similar survey was conducted. Now we had 5 IT companies and 1 energy company. Now, how these IT companies managed to be there in the top list? It was just because of the amount of data they had, and they realized that they have the ammunition on which, if they work, it has the potential to put them to the top level, right? And in 2016 only, there was an interview given by Eric Schmidt, ex-CEO of Google, and he said, right from the beginning of the humanity, right from the time we have started collecting the data, till 2005, the amount of data which we have created, we human beings have created, is 130 exabytes, right? Now this is humongous data. And he said in 2016 when he gave the interview, he said, now every 2 days we are generating this much of data. Now just realize how much data we are talking about. To understand the scale is important. To learn the algorithm is easy, Now we have everything as a black box. You just say that I want to apply this algorithm, pass your data, and then you get the insight. But unless until you understand the scale, volume, probably you will not appreciate the result what it is, right? Just to make you understand what size we are talking about. Alphabet A will take how much space? Right? Yes. You take 100 of characters, it will take, you can fit it into 1 kilobyte, right? If you take, you increase it by another 1,000 times, probably a book, right? You can fit it into the size which is called 1 megabyte. Human genetic structure, genomes can be easily fitted into 1 GB. You will say that human beings are not only about genetic structure. It is also about their activities, their achievements, their thought process, right? So you start capturing everything, right? And assume that everybody lives for 80 years. So all of this can be accommodated in. Making sense? Right? I'm just trying to show you the scale, right? Now this is Amazon forest, right? Where you have 1.4 billion acres of trees. And if you just chop it off and put it on some silicon paper kind of thing, just imagine this kind of space it will take will be. You increase it by another 1,000 times. This is 1 exabyte. Imagine how much data we are talking about, 130 times of it in 2005, right? I'm just putting it, whatever I just said, I'm just putting it here. 2005, 130 exabytes, 2010, 1,200, 15, 7,900, 2020, 40,900 exabytes, right? Or you can say 40 gigabytes. We are talking of this volume. Now you just plot it, right? This is the data which I just spoke about in the previous slide. Only a small portion of data can be seen, processed, understood by the human beings, which we call data scientists, right? A little more if you take can be seen, processed, understood, you can make sense by machines. What about this? What about this portion of data which can either be understood by we human beings or by machines? So here comes the need of where you train machine to learn on its own, right? You have to believe because Tim Berners-Lee, the inventor of WWW, he says that data is a precious thing and will last longer than the system themselves. So we know that system technology keep on changing, but the thing which remains is the data. And Vinod Khosla, co-founder of Sun Microsystem, he says that in the next 10 years, data science and software will do more medicine than the biological science itself. Just to understand, how we have landed to this situation, let's look at the evolution. Universe was created around 13.8 billion years ago. Earth was created 4.54 billion years ago. Modern human beings, we 300,000 years ago. Civilization started from 12,000 years ago, and the written record is available since last 5,000 years. And since then, the growth has continuously been there, seen in two areas specifically, data and technology. So growth of data was going gradual, but suddenly because of internet and social media, it started off very fast. Exponential growth which you see, it's because of this, And we are all culprits, all the hashtags, all the likes, all thumbs ups, these are all contributing to the data. Technology. Why technology? Why I am talking about technology here? Because of technology also lots of data gets generated. And you name it, you name it and it is there. So first IR to second IR, 100 years, right? Second to third, almost 100 years, 80 to 90 years. Third to fourth, it is 60 years, and now every day something or the other is coming up, and two technologies are coming together to give rise to third technology and generating lots of data. So you have to understand how the data is getting generated, why it is, what is the reason of this scale. We are growing naturally. What went in our life, what went in the society, why so much of data? So one reason is your technological growth also. Is data science new? Certainly not. It has been there. Now I'm just showing you the proof, almost century back. So there's a book by R.F. Fisher which talks about design of experiment. And here for the first time, ANOVA concept, which we keep on using, analysis of variance, was mentioned 100 years back. And so on and so forth. There are so many people who have written so many things. Quality control is not a new thing. Somebody wrote about quality control in 1939, right? 1977, exploratory data analysis word which we are using so commonly these days came into play. Machine learning book, the best machine learning book was written in 1997 by Tom Michel, and till date it is the best book in this area. 1996, Google, I'm sure you must be aware that Google is the research work, outcome of the research work by Larry Page and Sergey Brin. They were doing their research, PhD research in Stanford. So what I essentially want to tell you on this slide is it's not new. So it has been there. So since the time you have data, you have been doing something to understand what it holds in it, for it, and important for you to know. But there is a confusion, constant confusion. You have so many terms and you get confused. The first confusion is, the reason for the first confusion is the industry itself, So maybe 25 to maybe 30 years back, we had a position called statistician. What was the job of statistician? To gather and clean the data, to apply statistical methods. But then with time, the data grew, the technology also get advanced, and then they started extracting some patterns, right? Isn't it? We are aware that statisticians do this, right? Around 25 to 20 years back, till 20 years back, we had a position called data mining specialist. What was their job? Gathering and cleaning the data, applying statistical method with time, data grew, with time technology also got advanced. They kept on extracting the patterns, but then now they came up with new models, right? And what was the purpose? To get some accurate forecasting. Then we had a predictive analytics specialist. What was the job? Gather and clean the data, apply statistical method, extract patterns from data, perform more accurate forecasting. So all of that, right? Nothing is excluded. What statistician was doing, nothing is getting excluded. And now we have data mining, data science, right? And he is doing all of that which all the predecessors were doing, right? So nothing new. So if you feel that you can become a data scientist without having knowledge of statistics, not possible. Please understand, not possible. That is the foundation. The second confusion was because of HR managers. So they basically, with their maybe not so very clear understanding of the positions, they used to advertise something and they used to interview for something else. Right? So that used to be creating lots of confusion. So data scientist is somebody who knows good statistics and who knows good computer science. And somebody, Shlomo says that data scientist is a combination of statistician, programmer, coach, storyteller, and artist, right? And then there are a couple of fields which is must for this. I have already told you maths and statistics. You will need programming skills also. You will need the visualization skills also, and of course, last but not least, you have to have the knowledge of in-depth knowledge of domain, right? The domain for which you are working. What is the need of data science? As I told you, because of the industrial revolution, there is a generation of lots of data, right? Most of the data were unstructured. Now, I'll just tell you a small point here. Is before 2010, right? Before 2010, we were generating the data, but we were struggling to store it efficiently, right? But around 2010, we got a framework like Hadoop and Spark, which allowed us to store the data. So after 2010, we were in the best time where we had the data, we had the mechanism to store it, we had the algorithm to apply on it, and we had the insights. So before that, we had data, we had most of it in unstructured form. We were having good data storage facility, but what we lacked is predictive capability and also we were not able to get the scientific insights, right? Now, when you get the capability of predicting, right, and you can make this sense out of the data which you have, you can make some decisions, you can find out some patterns, you can do some predictions. When you can do all of this with your data, you can say confidently that you are in the realm of data science, right? Let me just give you another picture of the same thing, black and white and colored, right? So earlier we used to have most of the data as structured data. So all this structured data, it has to be brought at a single location for analyzing or getting a larger picture. For example, if banks have got multiple branches, right? Each branch stores their data in a structured format. At the headquarters, all these structured things will come and get stored in data warehouse, which is again a structured thing, right? And you have some traditional BI tools which you can apply or integrate with it, which will give you some pre-decided reports, right? Like you would like to know which product did well, which salesman did well in this season, what has to be sold. So all those predetermined things can come into surface, right? But now we have structured plus unstructured data. We have Hadoop, which allows us, Hadoop-like structures, which allows us to store our data. We also have good algorithms, good algorithms to deal with structured data, good algorithms to deal with unstructured data. And when you apply all of this, you get good insights on which you can take some good decisions, you can make some predictions, you can find out some patterns, you get to know some associations, right? And this is what is the need for the data science, and it basically allows you to improve, as I already told you, it allows you to improve the decision making, make some predictions, find out some patterns, generate data itself, right? Let's very quickly cover the ecosystem. So once you understand the ecosystem, probably it will be easier for us to know the product. Right? So data science is the combination of two things: data plus data science algorithms. Right? So data can be traditional or big data. Right? You have to have it right at the beginning. And data science algorithm can be further divided into three categories, broadly divided into three categories. That is that is business intelligence, traditional methods, and advanced methods, machine learning. Right. So business intelligence. See this probably I want to tell you with bold italic and caps. Like you can call it business intelligence, you can call it exploratory data analysis, you can call it descriptive data analysis, you can call it simple statistics, you can call it analysis. But essentially, what you are trying to do is you are looking at the data, historical data, and trying to understand what that data holds for. Right? There is a difference between analysis and analytics. So when you look at the historical data and try to understand what is the behavior and distribution of the data, that is analysis. And when you use the same data for looking in the future, that becomes your analytics, right? So once you have the data, what you will do? You will apply your business intelligence or exploratory data analysis to understand, right? What are tools you can use? You can use statistical tool, mathematical tool, programming tools, problem solving tool, and data management tools. So business intelligence, as I told you, you will have to use your historical data and understand what is meaning and purpose of the data. And then you have traditional and machine learning. Both of the things have got single goal, right? They help you in looking in the future, right? The only thing is, traditional methods are advanced statistics, whereas machine learning has got machine learning. So when you have traditional data, go for traditional methods. When you have big data, you can go for machine learning. But for trial, you can go with the traditional data and apply machine learning because you have to learn the algorithms. So for practice, you can do it, but in ideal situation, this is how it goes, right? Now, for example, just imagine that this is a sphere of data science. That means this is a world of data science. This circle which I am showing you. How will you start? You will start by, I'm not sure whether you can read it, but I'm just telling you, listen to me carefully. So you will start your data science journey by understanding the problem. Now problem can be told to you, or you have been given the data set and you have to make sense of it. So it can be either of the ways, right? You have clear-cut problem statement, or you have to find out what is the hidden thing encrypted in the data. So both the routes are perfect, nothing is wrong, right? Let me take one route, like you have the problem statement comes to you. So you have to understand the problem statement very, very clearly, because if you have not understood it right, your entire journey will go in the wrong direction. So do not be shy of asking questions, right? Ask as many as questions possible to find out and to your script your problem statement properly. Once your problem statement is there, second part is you will gather the data. The data will not be available to you right away. You might have to search at different locations to find out the data everywhere. Once you get the data, you have to find out if, is there any null, is there any misspelling, whatever, right? Is there any flaw in the data? If at all it is there, you have to clean it, right? In case if there is a transformation required, please do that also. So all of that in step 3. Then comes your fourth step, which is exploratory data analysis. Now you will feel that my data is clean, ready, let me jump and build a model, right? You will be in a hurry. My suggestion is never do that, because if you skip this step, you might probably be not aware of what is the important feature. To know about the important feature and then build a model around it is important. So my suggestion is this step is very, very important. Never even try to skip this. And many of the insights come at this stage also. Many things you will get to know at this level. Once you have understood your data, you go ahead and build the model. Now there is no mantra which will tell you that okay, this is the situation, go ahead and build KNN. Go ahead and build decision tree. There's no mantra. You have to keep on trying out at least on a couple of models, build a couple of models, and then see which one is performing the best. This is not simulation. You have to understand, right? Once your model is built, you have to show the result to your end user for whom you have done this model, right? Your work is not done. You have to deploy it and deploy it in the real time scenario and then see whether the model is behaving in the similar fashion as expected, right? So this is the entire life cycle of data science, what you are expected to do it. Let's just see. I have come back to the same sphere which I called as a world of data science. Now once you have this sphere, the sub-sphere will be data analysis. Then you will have data analytics, you can call it data mining also. And one specific case of data analytics is text mining, right? So I have just taken one route to make you understand, right? So how will you start? You will start with the data, right? You will gather the data, of course. Before that, you will understand the problem statement. Then you will gather the data. Then you will convert and clean it, convert it into a way where you can perform your analysis, right? Then you will come to data analysis phase where you will use the same data and try to find out what is the structure and behavior of the data, what is the trend. See, many of the things you will get to know at this stage only. So please do not be haste and jump, right? Once you have understood your data, go ahead and build. Go ahead and try to know the future, with data analytics. Now there are two ways, as we have just seen, traditional method and machine learning. So traditional method is nothing but your advanced statistics, right? Whereas machine learning starts with artificial intelligence, which says that the machine should have all the capabilities which we human beings are having, right? We can see and understand, we can listen and understand, we can reason it out. All of that, the effort is to let the machine also have all of these capabilities which were exclusive to us. Now the first step towards this is machine learning, where we have trained the machine to learn on its own. There are ample of algorithms towards this, but one algorithm which is called neural network is totally imitation of human neural networks, right? The way we see, we take the input, we process it, and then we take a decision. We add our own experience also there. It's not just that we process it, we add our own experience and then we get the output, right? Same way neural networks also does, And when you have this processing done multiple times for multiple reasons, this becomes an exclusive case of neural network, which is deep learning, right? And then you have RNN, CNN, and so on and so forth. I'm not going into that, but then I hope this story is clear so far, right? So data analytics, which is looking into the future, can be done in two ways. That is using the advanced statistical method, traditional way, or machine learning. Now coming to text mining, why I have taken this equation? Because for most of the unstructured data, it is the text which constitute the major part, of course the images also. But all the Gmails, all the tweets, all of that, documents, all of that is text, right? Now how you will make a machine to understand this unstructured? You need something in between, right? And that something which you need is natural language processing. So it sits between your algorithm and your data, right? And it translates, converts the data in such a way that your machine learning algorithm can function. Once you have done your analytics, you have to show your results through some data, right? Now, this particular thing, I could not show it in a proper way. What essentially I want to show or tell is this entire thing, this entire screen, what is there in front of you is the world of data science. Rest everything is either data itself or an algorithm or a tool which is used to analyze or a mechanism, something, right? Everything on the screen is the world of data science. Either it is a tool or algorithm or data itself or method, right? Which will help you in reaching your destination, right? So we can define it as like this. So what is the data science? You extract your data, you clean it, you analyze it, then you perform some analytics, and then you get the insights. Two things are not there on the screen. One is extracting the raw data from the source, which is equally important, and the second thing is converting those insights into data products. So you can very confidently say that data science is a journey of data, raw data, to get converted into data. Right? Any confusion so far? I'm sure must not. So what is data product? DJ Patil, who was a former US chief data scientist, he says that a product that facilitates an end goal through the use of data. So you are trying to achieve your end goal with the help of data. Right? So this can be taken as a definition of data product. So you are trying to achieve your end goal with the help of data. So there's a twist which I'll just come on to that. So let me just quickly define it for all of you. Our data products are system models that help us understand the data in order to gain insight and make predictions. There's no confusion, it is very, very simple. Data product is a production output from statistical analysis. So analysis which you do can also give you some insight which can be converted into data product. Data product can automate complex analysis task and use the technology to expand the utility of data informed model algorithm. So from simple analysis to complex analytics, everything which gives you some insight is called data product, right? Let me just take a case where we have considered Uber as a data product, right? We all have heard about Uber, right? So we know that AI/ML is going to change our world and IoT is going to make the life simple because there's lots of data that gets generated, right? Now coming to this, why Uber is so rich? Is the availability of car makes it rich? Does it have any car at all? No. So what makes it rich is data. Data. Now data is data enough to make Uber rich? No. You have to analyze it. So you have to use your data science capabilities to find out some solution, right? To find out solution is the second thing. What should you have first? Before that, problem identity. Problem identity. So we will take one problem, right? Now, I'm sure we all must have observed that when in the morning when you try to book your cab, right, you will find that tariffs are very high. Have you all observed it? Because everybody has to go to office, students have to go to school or college, right? So because there is lots of traffic, the tariff is so high. The tariff is high because there is high demands for cabs. Higher the demands of cab, higher the tariff, right? So how to address this? How Uber addresses this? Uber activates a surge pricing algorithm, right? This is an algorithm which runs at the hindsight, right? Which gets triggered the moment your balance gets disturbed, balance of your ask for the cab and the availability of the cab, right? It is the algorithm ensures that the cab drivers which are there in the vicinity, not in your area, also get fascinated to come to serve it, right? And all of that is guided by principle. It's not that you just are booking and Uber is playing with you and increasing the price because you are trying to book it very hastily, right? And they understand that you are in need and they increase the price. It does not happen like that. The moment the demand supply equation changes, the algorithm gets triggered, right? And most importantly, it is guided by the principle. The principle says that anybody who is trying to book the cab through Uber should get a cab, right? And second is there's a choice, right? You may go for this, you may not. It should not be thrust upon you that okay, now you have viewed it, you have to go. There's a choice that if it is important, you will go If it is not that important, you can wait for some more hours and then go when the prices go down, right? So this particular algorithm is basically to ensure that the market is rebalanced, right? Now, when this algorithm gets triggered, the cab drivers who are not there in this area and they're in some other area gets the notification they are free, so they get motivated to travel or drive through all this area and come to your region to serve, right? So what benefit you get? For drivers it is an incentive, and for riders it is a premium. It is important. If you have to attend the conference, you have to reach here on time. You will go the higher class, right? How it is getting so effectively implemented, because first thing it is controlled by the algorithm. It gets updated on real time. Hyper local zones thing is there, which is embedded. What is it? The entire geographical region is divided into zones, hexagonal zones, and every zone has got registered cab drivers. So if all the drivers are exhausted from this zone, the cab drivers from the nearby zones or the closest zones get motivated to serve in your zone, right? And additional features like if the driver is available, if it is there. So all those features can be categorized under additional. Right? So first step is your identification of the business problem. So we can define the business problem like this: to build a dynamic pricing model that takes effect when the lots of people in the same area are requesting rides at the same time. So problem statement is clear to all of us. What will you do next is you will collect the data, right? So data will get collected through apps, maybe holiday list will be needed, and so many data through sensors will get collected. Now all of the data which you collect might not be needed, right? Like suppose you might be collecting the data regarding the hotels on your way, right? That is not needed. You might be collecting the data about libraries, that is not needed. But the data regarding to the holiday list might be needed, because why there is so much of help? Is there a holiday today or that particular day? So all those things which are pertaining to the problem statement should be kept, and rest can be kept aside. And then, as I told you, you have to do some exploratory data analysis so that you understand what your data is trying to speak, what is the distribution and behavior of the data. Then you will build a model. I am not going into the details of building the model, but you will build a model which will run the search pricing algorithm, right? Then you have to validate it, right? So any new data which is coming has to be validated. How will you validate? You will validate it with the historical data. See how you test the model. You divide your data into two parts: train and test. So with train data you build a model. With test data you check whether the model is working exactly the way it is expected to or not. Right? Now, if suppose the model is not working as expected, it will again go to the data scientist. He will work on it and then it will get deployed. Right? This is just a visualization of Uber product at UK, which tells you what are the area where lots of accident happens. Right? What are the other data products? Can we have some here?
Swiggy, Zomato.
Yes. So let me just take you through this quickly, and then we have to see what is not a data product. Everything which you feel is a data product may not be data product, right? So all the recommenders, right, are the data products. Amazon, Flipkart, Netflix, whatever, and surprisingly, whatever they recommend, you feel that it is exactly what you wanted, isn't it? Most of the time. So it is so perfect. For example, like you have seen a pair of shoes on Amazon, right? Then you go to YouTube, you will see that those, and you come out without buying it, without shopping. You come out, you go to YouTube, you will see that all the same set of shoes are following you. You go to Facebook, it will be following you unless until you shop it or they get fed up that you are not going to buy it. It was just a bit of shopping, right? Your smartwatches are the data science application. So I'll just quickly come to this place. So is everything available on web is data product? No. Why no? So the definition says, we just saw the definition a couple of minutes back, right? So when you use data to achieve your end goal is your data product, right? Now all the web projects, whatever you see, products, whatever you see, right? For most of the part, they use data to achieve something, right?
Yes.
But then, how it gets differentiated from the data product is like the prime objective of data product is to make use of data to achieve its end goal. Let me explain it more clearly with example. So you have three products here. Can you see three products? Instagram, Gmail. So is Instagram a data product? Yes. Okay. In the interest of time, let me just give you the answer. It's not a data product because what is the primary objective of Instagram? It's a social media platform, right? It allows you to exchange, right? But then specific facility like tagging, search, discovery, all of that is data product. So special functionality, specific functionality is data product. However, Instagram is not a data product. It's there on web, but it is not a data product. How about Gmail? It's not a data product, so I have explained it perfectly here. Gmail is not a data product because it allows you to exchange mail, right? And but then sorting, your filtering, spam filtering, all of that is a data product. Google Analytics?
Yes. Yes.
It's a data product because the prime objective is to bring the quantitative understanding of online behavior. So I hope you have understood what is data product and what is not. You have to look at what is the end objective of that web product. Now, every web product does not make it. One more example to make it pakka. So this is Medium. You all know Medium, right? What is the purpose of Medium? It's a publishing platform, right? So it can certainly not be. So Medium as a publishing platform cannot be a data product. However, its search engine is a data product. Its article feed is also a data product. Right? What are the types of data product? So what qualifies to be a data product? The raw data, you have data, you can sell it. That becomes a product. You can do some modification, some processing of the data. You can share some derived data. Right? That also is a data product. So raw can be sold, processed can be sold, algorithms also can be sold. Algorithm as a service. Like Google image, you just take a photograph and then it converts and tell you what is that image all about, right? That's an algorithm as a service. You have a decision support system as a data product which allows you, helps you to take decision. Then you have automated decision making product also where you have entirely outsourced everything, right? You are not suggesting, you have outsourced. So these are the 5 categories under which you can have data products. How will you interact with the data product? Yes, very good. So you can interact with those data products through APIs, through dashboards, through web elements like voice and other things, right? What is the simple strategy to develop a data product? You have to define your aim, what is the purpose of designing that data product. Then you have to set up policy. Then you have to plan how you will do, and then you have to do the entire data science life cycle pipeline so that you achieve that, right? So it's very, very easy, and I'm sure next time when you do something, you know that whether you are building a data product or you are building a product. Thank you so much. I hope Thank you so much.
Thank you, ma'am. Thank you for your valuable words. We totally understand what is a data product right now. And we are in the position as budding engineers that we will definitely try to inculcate the habit that this data can be also become a product. Yeah. Now I request Sachi sir to facilitate, ma'am. Okay, now I request Dr. Parag sir to start with his keynote. The title is Generative Choice Computing, Decoding Humanized AI.
Those students are engaged with the offline session. Kindly go start 11:30. So I think the keynote will be not over 11:30. So try to join 11:30. Those faculty members already assigned to control the sessions. So kindly start 11:30. And offline will be start after the keynote. So
Okay. I think the time is going to eat in my audience, right? Okay. Anyway, uh, I'm going to tell you stories. Stories about choice computing. And this is actually a new paradigm which has emerged after I have worked in industry for more than 30 years, then developed various products. And interestingly, actually, we built some products which we think that based on choice computing have been used by Tata Consumers, Nestle, Envestnet, and many other leading players in the world. So I will actually try to tell you this very interesting concept and how this concept emerged. Because what was actually the motivation behind that? And I believe that you can give it a different word or different title, but this is going to be the way, or one of the ways, for future technologies. Okay? So let me begin. No, I have. Yeah. Okay. So basically, this actually already most of you were there yesterday, so we know about this, so we don't need to tell details. This is my book on choice computing, which is published in 2022. And then I'm coming up with a new generative choice computing book, because whatever everyone started talking generative, I thought maybe I will also be generative. Okay, so there will be a generative choice computing book that will be out shortly. These are a couple of the books. AI book is best-selling book, and this is the reference book for 60 plus universities in India. And my PhD candidate, she was PhD candidate now, she completed PhD 10 years back. Prachi is also co-author of this book. This artificial intelligence, reinforcement and systemic machine learning and so on. So these are other books. And knowledge innovation strategy already I talked, I think not to this audience, but Raisoni audience many times. So anyway, all of you know, which is forward and endorsement by Ratan Tata and Dr. C. There's another book, YD, which is very close to my heart, because which is a story of one of the YD students from Raisoni Institute, who became entrepreneur. And interestingly, Sony TV actually adapted it for a TV serial, and which was directed by one of the very well-known director, Samir Patil, who was also director of that Poster Boys and Poster Girls movies. Okay. Anyway, there are a couple of other books, and I'm writing two fictions now because I thought that I'm writing too much technical, and probably I should start writing fictions. And I believe that I'm good at fictions and poems than technology. Anyway, so you will hear more shairi than technology today. Okay. So these are two other books I'm writing. AI for creativity, I'm writing with Dr. Ellen Patnaik. Actually, you know him, and he's a very close friend of mine, very senior person. And there is this I'm writing with Professor Vidyut, Digital Business Innovation, and one Japanese professor. And this book came really well, and just recently I will publish it. So maybe next time I will have these two books for you. These are some snaps I had. There is actually Vigata Times and Mainichi newspaper. Those are like Times of India of Japan. They have published few articles about our work in Japan and about our knowledge strategy and all that. Just I thought maybe. So well, let's start story. This is my favorite example. This is from based on the books by Harari. Around 6 lakhs years back, there were only two species like us, Neanderthals and Homo sapiens. Neanderthals basically were very huge, very organized, very systematic, right? Probably data scientist. Okay. Neanderthals were very, and probably on any day, they would have crushed Homo sapiens. Homo sapiens were weak. They were short stature, maybe 4 feet, 4.5 feet, maximum 5.5. They were a bit agile. On any day, if Homo sapiens would have confronted Neanderthals would have crushed Homo sapiens. But that did not happen. Homo sapiens survived. That is, we survived. We survived to rule the world. We survived to change the world. Why did it happen? So there are different stories about it. Many scientists told that there are different stories. And I have my own take on that. Okay? And since I am an AI guy, I have my own things to look at it. Basically, I think one definite reason is agility. So adaptation to the change. But adaptation to the change is not very easy. It doesn't come for free. So there is another very interesting thing. Is freedom. Next point, which I actually think is a changing point, is choosing. Homo sapiens were very choosy. They were intolerant. And intolerance allowed them to look at things differently. And then another thing is learning from uncertainty. For example, what happens? If there is uncertainty, we generally become stressed. Today, you see, I have observed in even Tokyo International University, My wife used to be counselor for university for healthcare, and many students are stressed, they're depressed. Okay. Sometimes we think that education quality, whether improved or not, we are not very sure. But we were also doing a lot of efforts that time. But they are stressed. Okay? And their creativity on an average is going down. Maybe they are doing something interesting, they're very few good guys. So why it's happening? So probably learning from uncertainty is the differentiator. And we somehow, Homo sapiens have this ability. They will overcome it because we are Homo sapiens. But remain Homo sapiens is the challenge in this AI world. We have to remain Homo sapiens and not to become Neanderthal. So with so much information around, there is very high chances, and then I will come to it. But so I'm for non-obvious, new and useful. So what these are the four areas I am presently focusing my research on: choice computing, AI in creating, learning and decision making in uncertainty, choosing in uncertain scenarios. Okay, these are the areas I'm working. So what I thought, maybe I will give it in unconventional way. So I will tell you stories about the companies I worked and how this choice computing concept came in my mind. And then what technicalities we put in this choice computing and what the choice computing future will look like. Okay? That is what I'm going to tell you. In case you have any question, you can ask me any time. And if you want to know more about what we researched, definitely, and I'm open to that. Even anyone wants to do some sort of choice computing collaboration, would be happy. So, but before that, let's have a poem, because now we have too much philosophy. So let's do this a poem. So I thought maybe a poem on AI, because it could not be other shares or other something like that. So I made a product that wanted to learn. I made a product that wanted to learn, sensing all the data, keen to change the world. I made a product that wanted to learn, sensing all the data, keen to change the world. I spoke to product to understand the problem. I spoke to product to understand the problem, wrote some code to make it learn again. Product never learned. Product never learned, kept fooling me for years, taking all my data, left me only in tears. Product never learned, kept fooling me for years, taking all my data, left me only in tears. AI is thinking and breaking old patterns. AI is thinking and breaking old patterns. It is not just teaching machines, but saving your intelligence. It is not just teaching machines, but saving your intelligence. So friends, that is the philosophy with which we are going to move ahead in today's talk. So our choice stories. So let me start with stories. What are the choice stories? So I will tell you the story of ideas. Maybe there is a let me begin from start. I think since that parallelly that session is going on, we can have time, right? Okay, so maybe we are not obstructing that anyway, correct? So what this idea story is a very interesting story. Three great engineers from India. One, Subhash Gupta. Another is Sanjay Naglia, and third is Ravi Mehrotra. Subhash was a master's from Delhi University, and he completed his PhD from Stanford. Sanjay and Ravi did their bachelors from IIT Kanpur, and then Ravi I think Sanjay completed his master's from UC Berkeley, and I think Ravi completed his PhD from CMU. Anyway, there's nothing to do with school, but these three guys came together one fine day and they thought of starting a company. Okay? And then what happened? They had idea to give some sort of solution which can be more like a predictive forecasting, because we already talked, Neha talked about this predictive things, predictive forecasting was the idea. And they approached US Airlines, and US Airlines, I liked that idea, and they gave them one project. The project was the variable pricing. You imagine, before 1990, variable pricing was a completely new concept. So these guys convinced US Airlines that there could be variable pricing, like we pay different prices every day for Uber or for even flight. That you can blame Ravi for that. Okay, so Ravi Mehrotra actually had worked in parallel computing, and he thought same algorithm can be mapped to, because it's a constraint satisfaction, limited resources. You are trying to prevent the deadlock. Imagine the same concept in Uber. You are trying to prevent the deadlock. Same concept. He thought, you have limited number of seats in airlines, and you are trying to and he used these parallel computing algorithms and built wonderful algorithms. They got some money, but after that, before 1990, no one was ready to actually take it ahead. Then one fine day, Subhash and Ravi were at hotel Heathrow Airport, Hilton or Hyatt Hotel. And then they thought that the same concept can be applied to hotels, because there are limited number of seats, here limited number of rooms. There people travel from one hub to another. Here you go from Sunday to Monday, Monday to Tuesday, so there could be legs. There it's overcrowded in vacations, hotels are overcrowded in vacations. Right? There are special events, here are special events. So they just thought, they started a company, Ideas Integrated Decision Systems. And they had around 150 hotels. And if we are paying the variable price to hotels, we should again blame that Ravi and Subhash for that, because they are pioneer of this concept. Anyway, for example, I have to go to Mumbai and I'm paying almost some 8,000 plus rupees for that, some ordinary hotel near BKC. So probably Ravi has to be blamed for that anyway. So what happened? It was 1999. I was in Singapore. I was working on my decision systems, and I one fine day got a call from because I was thinking of coming back to India, and I approached, and then there was a Rajiv working in India office. He said that we are looking for a chief scientist or research head, and then I landed as a chief scientist for the same company. Okay, it was 2000, something around 2000. Interestingly, that time there was a foot and mouth disease in Europe. Foot and mouth disease is something like contagious disease, not exactly as horrible as COVID, but definitely it has taken toll on the market, and the occupancy was going down, and the customers started leaving ideas, and then they were not ready to pay very high price. So they thought that they want to solve the problem. And since I was heading the research in India, and Ravi was now the president and heading the research in US, they asked me to go to Minneapolis and then work on this problem from algorithm perspective. Can we solve this problem? So we had a lot of ideas. Three of us, Ravi Mehrotra, myself, and Errol Mora. Three of us were sitting every day discussing that what is to be done. We had a lot of new ideas and very nice environment, because I actually, whatever research I did, actually I can give a lot of credit to Ravi, because we have a very clear thought process. So we used to discuss that, And we had a lot of ideas, and we thought that we can solve this problem. But then there was a CEO Ed Booth, and Mark Robino was a marketing vice president. They were of different opinion. They say it's a marketing problem, and algorithm is good, and you should not change that and all that, something like that. But we're still doing whatever we were trying to do. Then even Mark Robino did a wonderful job. The financials were started looking on track, and then 9/11 happened. You know 9/11. There was that planes hit the Twin Tower. I was in US that time. I was in Minneapolis that time. And suddenly our occupancy went down like anything because no one was traveling. All the flights in US were grounded. Hyatt or Hilton, I don't know exactly which chain. They told us that we no longer will be your customers, and we were in serious problem. And we were supposed to solve that problem. So what we did, so I surveyed all the hotels, and I realized that airport hotels and three-star hotels are impacted very less as compared to all other hotels. So I thought, I have hit the jackpot. So I went to a booth and Ravi Mehrotra, we can sell it to three-star. He said, we already know. Okay, they are. The thing is that our product is so expensive that they can't afford it. Second thing is our price they don't have records. In 2000, probably these hotels, airport hotels, and they don't have data. And we have the yielding team, they work for 6 months on that data. Because all that what data science they did, Neha told we are doing manually that time, right? Because in 2000 there was no machine learning, nothing. We were actually had Excel sheets, some VB scripts, we were getting clusters out of it, and we were getting the patterns, and then there was an algorithm that was trying to tell that, though it's automated, semi-automated or automated, but the yielding team has to closely supervise it, and they said it's not possible, right? Because we can't take them on the board right away, and 6 months expenses and 6 months time with them is much expensive than what they can pay us or what they could pay us at that time. Okay. Well, then Morat and I stacked, and we invented incremental machine learning as a result of our discussion. I have almost a dozen papers on incremental machine learning. A very simple idea. We had 200 or 150 hotels data. We clustered that data into 12 clusters. Cluster 1, cluster 2, cluster 3, 12 clusters based on behaviors. Like for example, leisure hotels show different behavior, business hotels show different behavior. Correct? Sometimes two hotels in the same city and same location show the different behavior because probably their customer segment is different. So we had 12 clusters of the hotels. So we clustered them in 12 clusters. Then we mapped to some visible features of those hotels to those clusters. Okay. So 1, 2, 3. Now, suppose there is a new hotel coming in, we will map the features to one of them. Directly that forecasting will apply, and on second day they could go live. Okay. And as the data of those hotels keep coming in, incrementally we'll learn and the cluster will be adjusted. That was the idea. Interestingly, that idea worked. Ideas got more than 500 customers in 2002. Not a single employee was laid off, and Ideas was the only company which didn't lay off any employee after 2001. And Ideas was sold for a few $100 million, 500 or 600, to SaaS in 2012. But I left Ideas in 2003, so I could not. I enriched in the knowledge, but not enriched in whatever the returns. Okay, anyway, but the story is that that's why actually I have told in my research that line they excluded, that I am the research brain behind the multi-million-dollar success stories of Ideas and Capsule. So this actually, there is a choice computing thought that hotels want to choose. They don't want to be forced. That's the thought behind that. I will take it slowly, I will build a story. So there is a second case study. Location diagram. Choosing for paperless office. Let me tell you this story. I have witnessed that stories and I was part of those stories. And probably not a leading character, but definitely a major supporting character. Okay. Well, the supporting character though had a major claim, but they don't get credit like sometimes. So probably I'm the one who. So what happened? This is a story of one of the again entrepreneur from India. His father was very rich. He had a couple of bungalows in the Sin colony and then huge office in Nariman Point and all that and something like that. And they had three kids. And this elder guy went to North Carolina State University for his bachelor's. After bachelor's, he joined HP. A very, very smart, very intelligent guy, engineer by heart, actually. And very first month of his job, he went to bank to collect the salary. And even I told this story here maybe last time also, but very interesting story. So he went to bank to collect his salary. Those days actually there used to be a token, they used to do token, and this token used to be displayed on the board, and then when your token number is displayed, you're supposed to collect the salary. So he was waiting for his number. And then he saw there was one lady faxing the papers. So that lady took a paper, put in the fax machine, typed the number. Again put the same paper in the fax machine, typed the number. She continued like that. This guy, engineer at the heart, said that what this rubbish is doing, that putting the paper, typing the number, probably she could do it in a better way. Okay. So he went close to that lady and asked, Madam, may I know what you're trying to achieve? That lady said, we are a Fortune 500 bank, and one of the leading banks in the United States. And we have signed service level agreement, SLA, with about 5,000, close to 5,000 customers. And tomorrow there is a major breakdown. And we need to inform all these 5,000 customers. Otherwise they can sue us. Or we have to pay a major penalty to them. So he said that you are taking more than 1 minute to fax a single paper. 5,000 minutes, that's a huge time, right? How are you going to achieve this? He said, don't worry. We have many fax machines, and I have other employees at different branches. Super, everyone will start faxing. Okay. This guy asked, how many times you have to do it in a month? That was the old days of computer, very beginning days, 82, 83. She said almost maybe 7, 8 times in a month. Okay. Actually, they were thinking of creating a post for faxing, actually. So that was the story. So this guy, very intelligent guy, thought that he can solve this problem. He went home. And he wrote us along with Thomas. Thomas is a technical guy, and actually I had opportunity to work with Thomas also. So both of them wrote a simple code and developed a multi-fax machine. That code will actually take the numbers from one repository, take images of that particular file from other repository, and multi-fax machine, that switch will fax it in a second to all the faxes. And this guy built $100 million company out of it. The company's name is MediaTel, that he sold to close to 100 million to Capex. Then this guy at the age of 26 or 28, with 500 millions, right? Not married, because he married, his first marriage took place at the age of 45, which I myself attended in Umaid Bhawan Palace. So anyway, so this guy at the age of 28 with so much money, so he thought he should enjoy now. But then he was again engineer by heart, so he tried different ventures. Some ventures successful, some didn't work. And finally, on one fine day, he thought of this idea that there should be he, along with his friend Greg and Jim, went to San Diego. And on San Diego beach, while drinking. I should not say drinking, whatever they were drinking. Okay, or maybe they struck an idea. That idea was that there is a secondary, tertiary mortgage market in United States, and that works in very unorganized way. That if you have to sell, suppose loan, secondary loan, then they just randomly tell that this is the room, there are all the loans, and a person will randomly take some loans and say, okay, now it looks okay, and then just go through the list and say, buy those loans. So he thought that that problem could be solved. And paperless office, that was the idea. And he came with the idea. And I was founding member as a chief scientist because my friend Murli, who's again my friend and even a director of my company, he right now, Murli is from Kerala. He one find a call me that hey, NRI actually उसको कोई तो scientist type बनना चाहिए तेरे जैसा तो मैं तो scientist नहीं but ठीक है मिल लेते हैं उसको. So I just took an auto from Senapati Bapat Road to Kalyan Nagar. That Marigold CP was there. I think it must be there right now also. And actually, that time, that distance in 2003 or 4, I thought it's too much distance. I can't travel every day. Okay? But then I met this guy and I was so convinced. And he said, no, you're a founding member, chief scientist, and we have this dream and all that. So he sold his dream to me, and probably that's the reason I landed with Capsulon. Then he said, okay, we have to build this. I thought this is a very easy idea. You have to do a paperless office. What's great in that? So we started working. So what happened? That there are different types of documents in the mortgage, like deed of trust, then adjustable red note, adjustable rider, balloon note, balloon rider, and so on. Some of the files are like maybe 200 pages because if there is a bankruptcy, then bankruptcy report, police report, and all that. So what we thought, interestingly, that I said that okay, we'll just pass these documents and get the results. What is great deal? We said no, these are all documents in the paper form, and there are some digital forms, but those are fax type of thing, and the quality is very bad. So I said we'll get OCR. We thought OCR quality was not great. That time Bayesian classifiers were very popular, so we built a Bayesian classifier. And then we applied it. We used NeuraScript, Bayesian classifier. The results were 55%, 56%. He said it's commercially not viable. We can't build a product on this. Okay. So I said, then I want to. He said there is a person in United States who sits at San Diego who manually classify at the rate your algorithm is classifying. Okay. Then I said, Sanjay, I told Sanjay that then I want to meet that person. Okay. Who classifies so fast, better than my algorithm and much higher accuracy. I want to meet that person. So I went to San Diego. I had multiple meetings with that guy. Okay. Very smart guy. So I used to go in the morning and used to observe that how this guy is classified. Okay. And I think, and just 2-3 days I observed and I interviewed him, how exactly he does it, what he finds in that page. And then, one fine day, idea stuck. I thought that we will build a location line. A very simple concept. That there are some important keywords in the document. Okay? Those may not be a good OCR quality, but you may not identify those documents. So we will actually try to find out some sort of pivot points on the document. Then we will try to see some important keywords around it. Since it's an OCR unstructured document, the distance will be measured in terms of number of tokens. Okay? So from that pivot point, tokens, distance in terms of tokens, and such number of vectors will be built. These vectors we call location line. I made automated learning. So this is my first learning algorithm I made, which used to take those OCR document, used to apply fuzzy logic, and then first it will build these vectors on actual digital document. So those are 100% good quality. So it will get the repeated documents, and then there will be these vectors built. So a set of vectors will represent a document, not anything. So what is it? Let's say this keyword 1 in terms of token distance, keyword 2 in terms of token distance, keyword point, and all that. Interestingly, then with fuzzy logic, we applied it on this unstructured OCR document. Accuracy jumped to 98%. Again, Sanjeev said it's not acceptable because we are dealing with financial document. How are we going to do it? So we actually tweaked that algorithm. In 2005 sometime or 2006 beginning, we got the accuracy 99.9, and we got the first customer Pfizer, then Fannie Mae. The things did not stop. I even built algorithm, same algorithm I applied for extraction, because again you use the same thing, but extraction you can't afford that 70,000 rupees becomes 700 rupees. Right? So we had a snippet, so that instead of that snippet will be showed to the manual operator. The things work like that. I left Ideas in 2010. Ideas acquired by Illinois for $600 million. And we have 2 patents on location diagram. Sorry, Ideas not, Capsicum. And we have 2 patents based on this location diagram. Again, what I thought, we are using some sort of choosing. I will come to that. There's another story. We build it for investment. We consultant to investment. Investment is Fortune 500 company and one of the leading investment advisors. So one fine day, my friend Santosh was actually the HR vice president at investment. So he told his boss, that is the CEO or managing director, that Parag is doing some wonderful good work. So this Anilal was the managing director. Anilal called me, can you come down to Trivandrum, because we have their development office at Trivandrum. I went to Trivandrum. So he told me that they have a problem. And his friend Santosh thinks that Parag can solve that problem. I said, oh, I don't know the problem. How can I solve the problem? So he said, no, problem is very simple. We have a customer attrition. That a lot of people, investors who have registered on the platform, they are leaving the platform. Okay? And many times there are advisors, they actually personally contact the people. There are a lot of time of those advisors is wasted. So we want to optimize the advisors' times and we want to reduce the customer attrition. So I told him that we will approach this problem in a different way. We'll identify 2 things. Identify customers on risk, identify product on risk, and we will go. He liked that idea and we signed, same day he signed the contract with our company. 1 year. And we built a product which actually what it was doing, it was, in a way, again, I think is a choice computing thought started coming in my mind at that time also. That what it was doing, it was actually based on customers' interactions with the platform. It identifies what is the probability that customer will remain on the platform for next 2 years. What is the probability that customer will remain on the platform for next 2 years? So it will calculate. Second thing, for every product, based on the customer's interaction with the product, it used to determine which product will remain a good product for next 2 years. And third thing, it used to identify the core competencies of advisor and which existing customer they should contact So we used to classify the customers in red zone, amber zone, and green zone. Suppose someone is in red zone, and then that customer, the return ROI on that customer is very high, the advisor should contact that customer. Interestingly, 15% customer attrition is reduced with this approach. Okay? So what was the thought? That customer can't be forced the product, customer chooses the product. You don't like to be forced. For example, suppose if someone makes you compulsory, like attend this talk, so you may be uneasy, maybe leave the room after some time. But if you choose it, you think that I have chosen to attend this, probably you will remain here. That is the thought process of choice computing. We come to that theory. Okay. And then is we have offer, we have a product built for Tata consumers. I think I will go to theory because how much time we have? Okay, I will get, 25 minutes. Fine? Okay. So this story I will tell you later because it's a very interesting story. And this is the product close to my hand, close to my heart. And this product actually helped Tata consumers, and Tata consumers is using this product for last 3 years. Even Nestle approached us recently. They will start using this product very, very shortly. Now we also gave it to the therapy Singapore, and also there is a priority in Singapore and Indonesia. They are also planning to use the product. Anyway, I will tell about that. Okay. So what we do, we like to choose. That is the thing. What is a choice? Choice is not selection. Choice is what I was saying. It's your what you can say very inbuilt thing. Maybe sometimes you choose a very poor product. That is fine, but you choose it. Right? Sometimes you choose a course that may not be good for your career, but you choose it. So analytics is not always right. We have to listen to our heart because then you enjoy it. So what happens that if there is too much analytics, then where is your choosing? So there is a dilemma between analytics and choosing. So there could be a choosing in complex scenario. The problems does not offer choices. The data is sparse. Even inference is weak. Things look obvious but are not obvious. And then there are rules overriding the choices. So what we thought? Okay, how about when I'm looking at machine learning helping us to choose? So machine learning should not give us decisions. It should help us to choose. As an architect, as let's say maybe I'm a poet, machine learning should not write poem. I don't like it. It should help me to write poems. Okay? Machine learning should actually allow me to do something. And it should machine learning should not tell me what I should eat. It should help me to choose what I should eat. That's the idea. Okay? What is happening, most of the products are built, those are overriding human decisions. They tell you, okay, this is the thing you have to do. This is the course you should select. So there is a problem. So we are trying to look at this problem in slightly different way. So discover first thing is generate new options. So machine learning should not give you the option. It should generate new options. That's why it comes generative choice component. It should discover new concepts, nodes, and roots. It can combine 2 or more roots. The choice is a route. What I say? When you go to a shop, there is a choice path you follow. Okay? And that when you select a sari or maybe whatever it may be, kurta or maybe shirt or maybe mobile, that is a choice point. So what I'm saying that journey is my own. So machine should not interfere that journey. It should tell me that what are the possible routes, okay, without biasing me. So at the end of the day, the opinion should be like that. I have chosen. I should think that I have chosen. It's not data analytics. It's not machine learning, but I. So that's why I gave the title humanized AI. That's why the title is humanized. It creates new set of actions, redefine neighbors. Because for example, when you're choosing, it can help you to redefine. For example, it's online shopping. So it can redefine the neighbors that this product, that product. But it should not tell. It should actually give the neighbors automatic. You are smoothly going from one neighbor to another and finally selecting the product. Like you go to super shop, or you, not you, because we are very biased. Let's say kid goes to a shop and then you ask him to select. Right? So it will be very free flowing. Correct? So that's the thought and generating rules. So there's a very simple example of what I thought. It's evolving, evolution, and generating. It is evolving, evolution, and generating. Evolving means it could be genetic or something computing type of algorithm. Why? Because genetic algorithms tries to look at the sample space or choice space and generate new choice options. Correct? You know that crossover mutation, what it do? It combines two or more options, makes new option. It modifies, mutate the option, generate new option. So the idea is you can have. So it generate the choices. So this is a very one of the popular papers. We actually experimented with this type. For example, these are the vehicles. Then you have fitness function. Maybe you can have different functions. This could be any. You can define your own genetic operators. It should not be always two parents. It could be three parents. It's a AI, right? Why there should be only two parents? If it is a human generated thing, that's okay. But when you are AI, you are doing, there could be three parents, there could be one parent, there could be 10 parents, 100 parents. Anyway, complexity you have to look at, but computational complexity could be different. So probably you can have maybe this, you can have this type of genetic operators, wheel of one body another, abrupt wheel change, abrupt body change, partial color change, and something like that. You can have your own operators. Anyone has worked on genetic algorithm can very easily understand this. So probably you can get these type of vehicles. You will have a fitness function. You may have a dynamic fitness function, or you can have an evolution fitness function. Right? The idea even is that you can measure the fitness of fitness function. Idea is that even you can measure the fitness function of the fitness. So there could be a choice creating operators. The idea involves that you can have a choice creating operators. So if you look at it, these are the vehicles. So you may have generalization of properties using statistical algorithm. You already, all of you know that what is generative and what is discriminative. Discriminative means you are trying to differentiate. And generative means you try to look at the behavior, understand the behavior, and generate based on that. So you are not actually trying to classify. Okay? So that basic difference. It is exactly the same between analytical thinking and synthetical thinking. What is analytical thinking? You analyze, think that okay, what is that? Analyze the property, separate the property. What is synthetical thinking? That you identify the similarities. So you may look at okay, these two, they two have similar liking, they can work together. So this is synthetical thinking. Same way, discriminative paradigm tries to separate the things. Generative paradigms tries to understand the behavior. So maybe it may be very blurred, so it can just trying to encompass the behavior. Based on behavior, or you will call it prompts. Right? Based on prompt, there is a prompt engineering. A lot of other things are emerging. So based on prompt, you will try to generate maybe articles, substances, or whatever. So maybe you can generate, you may have prompts defined. So you may have behavior understood. What could be the behavior understood? Like maybe a triangle or a rectangle with two same size wheels could be the behavior. So it may generate this. This could be hallucination. That's what called as gene engineering hallucination concept. If you must have studied anyway. Everyone is talking Gen AI, so I thought maybe everyone understands it. So there's a hallucination. And the idea is that there are some facts, those are not actually there are some prompts, those are not actually based on the facts, and your creation is based on that prompt, then there is a hallucination. What happens that in human in psychology, what is hallucination? You start imagining something that is not there. Correct? I start imagining that I got Bharat Ratna, maybe Padma Bhushan and all that, then that is hallucination. Okay? So what happens that you start imagining, generating the prompt, try to exaggerate, correct? So maybe simple success you try to. So it is the next stage of dreaming. So you dream means you know the difference between reality. Next stage of dreaming means you think that dreaming is the reality. That's why I used to that Nash, the scientist who got Nobel Prize. He has that schizophrenic thing, and there's a movie, The Beautiful Mind. Everyone you can understand that how he negotiated with hallucinations. The wonderful person. Actually, the person with schizophrenia actually wrote the algorithm those no actually a person in senses could write, right? I don't know how he achieved this great thing. So anyway, so there could be maybe some geometric place, shape. So your prompt is wrong. So again, it comes to prompt engineering. So but I thought maybe all these things combined, how it would look like. So you have a crowd or maybe crowdsourcing or maybe data collection, whatever you want. So you have a data. What happened? You got insights. So choice making is personal, temporal, and influenced by neighbors and environment. So for example, my friend selected iPhone. There is a chance that I may select iPhone. Something. Because there could be some other. So many times what happens that your friend gone to a particular class, so there are chances that you go. So choice has environment. It's temporal. What you choose now, you may not choose tomorrow. Right? For example, some book, if you go to bookshop, you think that moment that I'm just lacking this book, otherwise I will read it in night only and do something. You take it home and never read it for 10 minutes, right? So, but that's a choice point. You think that is a temporal thing, very time bound. And then it is influenced by neighbors. So you have this thing. So what will happen? There is a behavior and features, and there is a generate new instances of that. So how it will look like? There is interested responders. There could be behavior and seeds. There could be responses, and then you may get generate ingredients, and then you will have a recipe, different recipe. So, for example, everyone in this classroom has seen some Sanjeev Kapoor's some recipe of akrod halwa. Okay? And all of you go home and then cook akrod halwa. Everyone's akrod halwa will be different. Though you have listened to the same recipe of Sanjeev Kapoor, right? Okay, my wife did it yesterday only, so probably that's why I'm giving an example of akrod halwa. Anyway, but I could have given some other example. Anyway, what I'm telling, so what I'm saying that the seeds may be same, what you generate is different. So it's a recipe, and you look at this, and that actually helps you. What you do. If you looked at that video only of Sanjeev Kapoor, okay, it was not that bad. Anyway, okay. So what basically is happening? So there are so many responders. So what we call it, what is it? There are so many choices generated. Okay. So initially what happens that only the central part is there. So you are creating so many possible color changes and all that. Then you will expand the choice route. So more choice routes. Okay. And then what that is, so generative choice computing is about generating more legal, rather healthier choices and creating the choice routes for users without obstructing their perceived behavior or freedom. So what is generative choice computing? So with all these stories, we came to this, sir. We came to this small definition. What is generative choice computing? What is generative choice computing? It is generating more legal or healthier choices and creating choice rules for users without obstructing their perceived behavior to them. I'm not saying that akrod halwa is healthy. Anyway, don't relate it to that. That was just an example. Healthier options. We'll come to that. Okay. So what I said, I thought maybe I can define it in Hindi. बंदिशों के बीच भी बंदिश महसूस ना हो, वो चुनिए सही ना हो, पर हमारा एहसास ना हो, इस चॉइस को। बंदिशों के बीच भी बंदिश महसूस ना हो, you should not feel that you are getting forced. बंदिशों के बीच भी, anyway you are getting forced, but you should not feel that you are getting forced. बंदिशों के बीच भी बंदिश महसूस ना हो, वो चुने सही राह, पर हमारा एहसास ना हो। My existence, that machine's existence should not be felt, but I will making them to select the right thing. That is choice. They should not feel the existence of machine. So this is choice engineering, and one of the inspiration is this book by Sheena Iyengar. She actually wrote the book Art of Choosing. Actually, I'm following her, and even I contacted her, and she was supposed to give forward to my book Choice Computing, but last moment I think her health was not well. She is one of the pioneer in choosing the theory, psychological theory, not AI. And she's one of the best professor at Columbia University. She got 10 times this award as the best professor. And she's blind from the age of 4. This lady, wonderful lady, but and even many times she respond to my Twitter also, some post also, but somehow I could not get her forward. But maybe for generative choice computing, I can contact her again. So I will come to that choice base because I think we have limited time. I will cover some important points, maybe next 10 minutes, and we'll conclude. That's fine? Yeah. And then we can open up for question and answer. This is very interesting, and a lot of technological part is there. My 2 PhD candidates are working on it. And even the Tata consumer product, which was outcome of one of my PhD students' work and my work combination. And now we are also trying to enhance it with choice computing. So I have a lot of case studies. Even this book, Choice Computing. So there is another thing. So what happens that pattern-based choosing. So what happens that many times we are too much formatted by the patterns. But pattern is not a right thing many times. Because then if we Neanderthals are pattern based, Homo sapiens are not following. So probably taking you away from the patterns is right. Me many times don't tell a lot of stories. I have few stories about it, but anyway, I'll skip that because we want to conclude in the next 10 minutes. Human factor matters. There's another very good book, Factfulness, is another inspiration behind that. So whatever statistical thought process I brought to this choice computing is actually inspired from this factfulness. And actually, as someone who is really interested in data, they should read this book, Factfulness. Very nicely written. There are actually one example this book has given, that there was a blank claim that girls score less in mathematics in SAT than boys. And then there was other claim that girls are not good at mathematics as compared to boys. And this guy actually said that that is really wrong, false claim, because you are looking at the average SAT score of boys and girls. That is not the way to look at. If you look at spread of SAT scores of boys and spread of SAT score of girls, then you will find that 92% of the boys and girls have same scores. What does that mean? Like 92% boys and girls perform in the same way in the mathematics. So what this blank claim makes sense? Only on average, so there are 8% boys probably they are doing something good, or 8% girls because of some problem they could not able to do that. So because of that, can you make the claim? So what I'm saying that it is really a wrong way to look at the mean. And many times statisticians and even the data scientists fool us by telling the mean, that average or something like that. So probably it's not the right way. If whether spread is the right way, we have to look at it. Anyway, maybe you can study more. So there are a lot of such things. Yes, you know, right data, wrong insights. You are looking at right data, but insights are wrong. Data, behavior, and failures. Then instincts that distort our perspective of the world. There is instinct that ये तो बहुत he's a great guy and he's bullshit, something like that. So we don't say everyone, it could be average guy, right? It could be average guy. But we like, okay, rickshaw wala chief minister बन गया, we like the story, right? For example, that guy who was there is there, so we like this difference. So I don't want to say that. but we like the stories, right? Yeah. So you want to, we like it. बहुत ही पूरा भारत का ये इतना कम था और अभी इतना हो गया. Right? People like that story. So this is human instinct that we want to classify in two things: poor and rich, intelligent, not intelligent. We don't like, okay, there could be 7, 8 classes, intelligent, thoda kam intelligent, right? Then maybe you may not be a poor country, you may be somewhere average, right? Maybe 7, 8. Right? We like that, we beat this country, we beat that country, we beat that country, now the railway line length is more than this. So we always like that stories, right? But stories, that's human instinct, and that's very good for selling. But what I'm saying that when you are a data scientist, you have to look at not only those factors, you have to look at more details of it. Because we are engineers. What is the difference? We are data scientists, we are engineers, we are machine learning engineers, we are scientists, so we have to look at different things. So basically, lean versus spread and 2 extreme class addiction. So there is actually one wonderful book, Nudge, again must-read book by Nobel laureate Richard Thaler. This is another motivation behind proposing the concept of choice computing. So this guy actually is a pioneer in choice architecting concept. Okay? So what is choice architecting? I defined in my own way. Maybe this Richard Thaler may disagree, but it's my definition. So anyway, you can. So choice architecting is about removing the constraints; those are fair, and putting the constraints; those are not fair. To maximize the freedom with the objective of well-directed outcome. What is choice architecting? Choice architecting is about removing the constraints, those are fair, and putting the constraints, those are not fair, to maximize the freedom with the objective of well-directed outcome. He has given some very good example. I will give a couple of examples and then conclude. Okay? One example he has given that school, there was one school, and then there was school canteen. School canteen में बच्चे जाते थे and they used to eat all non-healthy food items, right? And then child obesity was the problem. So उनका कहना था कि you should force the students to eat healthy. So he said that but then the principal was against it. He said that the kids should eat what they like. So they hired one choice computing guy. Or choice is not choice computing. Choice computing is our concept. Choice architect. Okay. So choice architect and told him that this is the problem. So he actually studied the behavior of students for a few days. Then what he did, he made few changes. Okay. He first changed the menu card and put the items those are healthy at the exactly eyesight of those kids, and unhealthy items slightly at the. Second thing is they displayed healthy items at the counter in slightly in a better way, okay, proper in more decorative way. And their claim is that 25% consumption of healthy items is increased. So what there is a human behavior. And many times AI doesn't take into account this human choosing aspects. Right? For example, what I like, what particular person likes. So probably this is choice architecting without student feeling that they are forced to eat that thing. Actually, they are made to eat healthy things. Then some may be adamant to eat that burger only, that's different thing. But there may be many, and they say that slowly the transition happened. So same thing is about choice computing. That and the idea of choice computing is not to do what is profitable. It is what is good, what is healthy. That's the philosophy. So computationally inspired choosing, computing to architect choices, and creative choosing by machines. So these are the three pillars of choice computing. So we have the framework of choice computing. It's very similar to reinforcement because I said that evolution, exploratory, and generative. Its combination of it is your choice computing. So you will have a choice space, you have rewarding generative, and you have choosing strategy. So your choice computing could be very well based on deep reinforcement learning. It could be very well based on deep reinforcement. So there would be generative choosing, it has attributes, you will generate choices, and you pick randomly those choices, and then you will verify them for the healthiness or for that fitness function, and then you will reorganize them. Okay. So idea is that. So it will be generative AI models that will learn, and it will be how the process is given that, which is the combination of all these things. So maybe there are a couple of stories, I'll just keep those stories. We actually worked on choice computing with these companies. Global Kutch, a very great initiative by Gujarat government, I had the opportunity to work with. There's one guy, June, he's in real estate, and we actually deployed a choice computing algorithm there. Then outdoor management is another concept, and my friend of mine is doing this, and we said that how the choice computing is done. Then Rajesh has a more garment business for him, and then vessel loading at Dubai port. We did some choice computing. So basically, it has we had 6 main aspects. One is inertia diagram, because we have inertia. So there could be an algorithm that inertia diagram. These are actually algorithms, but I tried to put them in humanized way. There is a less is more. So you have given less options, but very good options. Okay. Then story and relevance. So you will not just give options, but there will be story associated with it. So you will choose it. For example, if I tell a story that okay, this particular revolutionized investment, so you will say okay, his algorithm must be good. Then surprise at a critical point. For example, suppose the guy is showing you so many so many high cost fabrics, and suddenly he shows you some reasonable cost fabric, you will buy it. Correct? A lot of guys do that. Correct? Or he's showing you some pretty average appliances, and suddenly shows a very good appliance as compared to that. You may jump at it. So that's a choice point. So identifying that choice point and making them to choose it. Fifth thing is slow to hit and gradual cooling. So take slowly person to the choice, not directly put the choice on him. So slowly there are these models we build for the algorithm. And these are basically AI models. I've tried to put it or the machine learning model. And 6 is neighbor matters. So we'll choose when you are, let's say, on Amazon, let's say showing the articles. So those articles will show near, so that you not to make you to go to that article, but to select choose this article. Sometimes, or sometimes if it is choice route, to take you to that. That's how it works. So basically, there are some definitions. Choice computing is building ability in machines to make choices leading to the optimal goal state. So more in AI fashion. This could be the definition. There are 7 steps. We actually try to build a framework also. This is actually my next book, part of next book. So there will be like it will begin with the problem. Then there is a choice opportunities. So machine will identify choice opportunities. Okay. Then next thing is there is a choice model, which is not exactly machine learning model because it will consider all these 6 things I showed in the last. Then you have a value creation. So you will have a measurement of configuration. Then beyond the choice space, you will try to slowly expand the choice space to create new choices. Then you will actually consider the context to reorder the choices. Because for example, if you are coming from India, probably your choice is different. Maybe if you are arranging the food, if you are going from some other place, and then respond dynamism. Okay. So what I thought, maybe there are a few more poems for AI, and I will continue. So it's reinforcement or evolutionary, genetic, and generative evaluation. So these are the four things. Those combined choice component. So I thought reinforcement learning, how we can say it in Hindi. रोज नई परेशानियां नए हैं रास्ते हम सीखते हैं फिर भी आस्ते आस्ते उपहार मिले कभी तो मिली सजाए गई पहल हम करते रहे उपहारों के वास्ते. That is basically reinforcement machine learning. Okay. Genetic algorithm. पुराने ख्याल मिलते रहे बदलते रहे जूझने की काबिलियत बढ़ाने आविष्कार होते रहे. That is basically genetic algorithms. Generative. जानते उनकी खूबियां रूप कई बनाते हैं हम हर बार उसी मर्म को अपने रंग में रंगते हैं. It is a genetic algorithm. Evaluation means दोनों तरफ से हमें समाधान आते रहे कहाँ इंसान है कहाँ मशीन कैसे हमें पता चले. So there are challenges like hallucination. So I thought maybe challenges I can put in the poem form. मशीनों को इंसान बनाते बनाते खुद मशीन बन जाता हूँ. अब मैं असाइनमेंट लिख पाता हूँ मैं पैसे लिख पाता हूँ फिर भी डैश कहलाता हूँ. आजकल उनसे बड़ी बातें होती हैं. एलएलएम से एलएलएम की मुलाकातें होती है. न कोई खपा होता है न कोई बेवफा होता है. मशीनों से बस प्यार का इजहार होता है. मैंने देखी है एलएलएम की बड़ी कारगिरी. इसको इंसान का नाम दो मशीन को मशीन ही रहने दो कोई और नाम नहीं. थैंक यू. If you have any questions, I'm there. Otherwise, we'll stop there. Thank you.
Thank you, sir. Thank you for your valuable words. The way you ended was really, it touched our hearts. It can be represented in the form of poems. Really great. Now I request Sachinandan Mohanty sir to felicitate Parag sir. Now I request all the participants to proceed for the lunch, and after that we'll start with the offline session followed by valedictory function. Offline session will be conducted at room number 320.
At least 5%.
Okay, fine. We will do that.
A very good afternoon to one and all. It gives me immense pleasure to welcome you all for the valedictory function of International Conference on Intelligent Systems and Machine Learning ICISML 2024, organized by AI Department of GH Raisoni College of Engineering and Management, Pune. Edward has said, coming together is a beginning, keeping together is a progress, and working together is a success. So today, we are privileged to have such a distinguished mind together for a remarkable conference. The exchange of knowledge and experiences has been truly enriching, and we hope the connection forged here will pave the way for the impactful collaborations in future. On behalf of Raisoni Group of Institutions and GH Raisoni College of Engineering and Management, Pune, I welcome Dr. Sachinandan Mohanty, EAI Ambassador India and General Chair of ICISML 2024, our Campus Director, Dr. R.D. Karatkar sir, Professor Rachna Sabe, Convener and Head of the Department, AI Department, Professor Vaishali Bhaveskar ma'am, Co-Convener of ICISML Conference. I would also like to extend my warm welcome for all the dignitaries of the dais, research scholars, faculties and attendees of ICISML 2024 valedictory function. First of all, I would like to call Dr. Sachinandan Mohanty sir to summarize the key takeaways of ICISML conference and declare the best paper award.
Very good evening. As you know, every starting there is ending, or every beginning there is an end. Every sunrise there is a sunset. Again, next day we start with a new direction, a new day. Similarly, we start this ICML conference third version from last 1 year. Today we are concluding. Actual conference work start from today onwards. Then you can ask how it start. After submission of paper and presentation paper, the paper is not published yet. Unless until paper is not published, so your conference is not completed. So whatever you enjoyed the gala dinner or launch, social networking, everything. So today onwards, our publication team will start the work. Out of 80 paper accepted, we are yesterday around 2 a.m. I discussed with the Slovakia publishing team. 10% paper will go to the journal publication. So these are the 6 different Scopus index paper. Our publication team with the TPC members, those are planning to decide on 12th January. We will fix a meeting, online session. We will start the discussing out of what are the 10 papers. So they are requesting 10%. I requesting them to go for the 10 is round figure. So 10 paper will go for the journal publication. All are the implemented papers. And today we have around 60 papers presented. One is offline session and the online session. Rest of the online session. And 4 are absentee. And we have already given all the presenter certificate. And around 21 expert in different field, AI, ML, machine learning, something. So all the sessions there. Also, we have given all the sessions certificate immediately. And those are offline presenter of the certificate. Today will be circulated to them. And one thing we have decided is very difficult to find the best paper. The best is a fuzzy word, right? So we can call the relative word. We can find the best paper. All the 80 papers are the best paper out of 320 papers. So out of 80 papers, on the basis of presentation skill and the novelty and your presentation skill and some novelty paper, we decided 3 best paper hours. One is for the 2 is from offline session and 1 is for the online sessions. For online sessions, best papers goes to paper ID 341827. I congratulate to you. The title is Student Engagement Measurement and Evaluating Based on Machine Learning Approach by Liwa College, Abu Dhabi. So Professor Sri, I congratulate you. So you will get the coupon for the next conference is the free registration fees. Similarly, this conference, Pratik also there. In second conference, Pratik got the best paper award. So this time Pratik got the $150 total free, right? So we got the free coupon. So this is the tradition we are following. So what are the best paper? If you apply for the next ICML conference, so totally zero. There is no registration fees. So similarly, the two offline paper present the best paper award. So due to the both are numeric number after evaluation, both are the tie. The one paper is the 342582. The title is Forecasting Water Quality Factors and Predicting Utilities by 60 Bars. So I congratulate you. You just wait, we will give some token of appreciation. And another best paper award 342488, that is called the self-supervised learning with the generative adversarial network by Urpin Mehta. Is there? Yeah. I congratulate you. So if you submit your paper the next ICML conference in 2024 or 25, you will get a free registration. So no need to pay. So I'm going to declare here the next ICML conference we are going to organize in Nepal on November 27 to 28. So this is the first time we are going to organize at international level. So finally I'm going to conclude. So is there any something we did or some problem from our end or feliciting or something? So it will be very sorry for from our end. So we try our best. So they gave our I request the total team. So they given lot of efforts to given the best hospitality, best coding. So I appreciate that this is the out of three conference. I appreciate this is the only conference we given the high presidential accommodation and the high quality best food. And yesterday Gola night was super, and all the credit goes to Dr. Sunali. Yesterday totally the Gola dinner handling by her. And I heard one statement: every success man there is a woman. And today it is improved. Every success conference also women, not only the men. So these two chairperson can call the convener, Dr. Ratna and Dr. Vaishali and all the teams. So they given the grand success of this conference. So I request to give a big clap for them. So anything you want to tell, can few so Sonali madam will call, we give the feedback. So here I conclude. Thank you very much for coming, and wish a very happy new year to all. And those are coming from outside by spending 2 days time. So we have another after session over some sites in their balance. So it was a nice organizing. Thank you very much, sir, for giving opportunity to hosting the conference. So I try to build a good relationship for long term. So I associate, and today also I talk with the data science head of the department. We're planning for the one seminar, 5 days on cyber security and excellence. Thank you very much, sir.
Thank you, sir. Now it's time to acknowledge the author of Best Paper Award. So to acknowledge the students, first of all, I call Dr. Adi Kharadkar sir to felicitate the Best Paper Award student. First I call Kshitij Raj to felicitate. Now I would like to request Dr. Sachinandan Mohanty sir to felicitate the Urvi Mehta for Best Paper Award.
more धाम भी थे।
Thank you, sir, and congratulations to the winners who has proven the exceptional dedication, tireless effort, and scholarly excellence. We are grateful to have a very enthusiastic team. Without their support, this conference would not be possible. So I would like to request Dr. Sachinanda Mohanty sir to felicitate our convener, Mrs. Rachna Sabe ma'am and Mrs. Vaishali Bhaviska ma'am with the appreciation.
Next is, this is Sonali Sonali ma'am.
If you big clap, you for
Next is Yogesh Mani sir.
the key portion of the accommodation details.
Now I request Dr. R.D. Kharadkar sir to felicitate Mrs. Bhagyashree Mankar ma'am.
So total session there is
Nutan Raut ma'am. Next is Mrs. Ruta Raut.
Yes. Thank you, madam, for your report.
Mrs. Radha Shivakar ma'am.
Thank you, madam.
Mrs. Pranika Mungal. Ms. Barkha Kumari. Now I would like to request Professor Rachna Sapre ma'am to felicitate Mr. Sakaram Kotte sir. Closer is there? No. Dr. Snehal Karad ma'am. Mrs. Savitri Patil. Savitri Mane ma'am. Now I would like to request Bhaviska ma'am to felicitate Anjali Kaur ma'am. Mrs. Lakshmi Sharma. Mr. Ajay Sagar. Mr. Dheeraj Vyavare. Amruta ma'am is not there. Abhijit Khadke sir. Now I request Sachinanda Mohanty sir to felicitate Mr. Giresh Patil sir. Ms. Komal Jadhav.
Registration there.
Deepika ma'am is not there. Sharvil Sopal sir. Aishwarya Amar. Amit Kumar Shinde sir is not there. Dakshata Jain. Mr. Aman Singh and Vidya Dokina. And last, our main backbone, Mr. Dhananjay Kokre sir. Without his support, it could not be possible. If I have not taken anyone's name, but still many of them have supported. Swati ma'am is there? Okay. Swati ma'am. Swati Parikh ma'am.
You bring your certificate, no? Certificate.
Thank you all. We would also like to give a token of appreciation to Gala Dinner Cultural Performance. Your performances has made such an enormous impact on our Gala Dinner. So I would like to call Ashant and his team for the felicitation, and I request Karatka sir and Mohanty sir to congratulate the performer. Ashant and Ruchira is present here. They have done a fabulous job yesterday. So it is a small token of appreciation. And along with this, sir has given.
So during yesterday night, the moment I observed your performance, immediately I dropped a mail to EAI office, and they are already contacted with me WhatsApp, and also I am sending the video of your dance, and they see that you are organizing is marvelous, excellent. Then okay, you should appreciate them. So they said okay, what you need. Then I said you give some token of appreciation in terms of some dollar. So they given $50 immediately. So amount I given to your department, you will collect on Monday. Otherwise today only you can collect. So madam, I can give you just. So I really appreciate your yesterday performance. Thank you for giving your performance.
Thank you. Now I request our campus director, Dr. R.D. Tharatka sir, to give the concluding address.
From the yesterday and today, we have this conference that is the ICISML 24. And today I witnessed some of the events of the conference online and offline mode. A very good selection of the resource person, key persons, chief guest, and a very good schedule they have formulated. And timely conduction of the event with great enthusiasm, that is one of the differentiators, because being what we can say as a participant, as a presenter, as a judge, evaluator, I have been attending the many conference, and this is one of the best conference that I witnessed. And I am on the governing council of the Institute of Electronics and Telecommunication Engineers, and periodically we meet and take the review of all India activities. We also conduct the conferences, symposiums, workshops, and all that. Very meticulous planning is required for such activities, and very well done. And Manti sir deserves the congratulations. And on behalf of the Raisoni group and on behalf of our institutes, I congratulate the EAI entire team, organizing team, and especially Dr. Sakhi sir. And yesterday, Sankhya, so he has also contributed, he has given a good time for us. In gala dinner also, they performed well, that is, participants, they performed well. That is our local participants along with the participants coming from the different places wholeheartedly, and they did the gala dinner, "Hum honge kamyab." We cannot forget that. Really, that is a what we can say punchline. That is really, we are kamyab and we will honge kamyab, no problem. And we are eager to engage such activity in future also. We want the collaborations with the EAI. Our management is also observed, witnessed. My chairman sir was there yesterday for the lunch, and he also observed some of the events, and that has been created a very good impact on our college also. And we are eager to take some activity further. Okay. Lot of thanks to the participants who come from the different places in the physical mode. I learned that Andhra Pradesh, VIT Vellore, Rajasthan, Delhi, many people they have come here and they deserve the congratulations. Nowadays, after the corona, the habit has been developed, that is online mode and all that. But you people, you come here and wholeheartedly participated in all the sessions. I also congratulate the online participants because they were punctual and sincerely attended the papers and sessions. And a very good keynote. I was with Parag sir today. One patent we were trying to commercialize that patent, and that is in the basement. We are doing that. And there some participants come to the Parag sir, and they were discussing that is about their research topics and PhD topics about that choice computing and something. It is the real acknowledgement that is that I am observing. That is the person immediately after the session goes to that resource person and discusses and exchange the contacts. He was in investment and all that. That is a real acknowledgement. It shows that the conference is successful. Similar things they have happened for the other keynotes also, and I am thankful to the keynote persons also. Just some advice, that is your papers, your research, you try to convert into the products, prototype, incubate those things. Okay. And nowadays for cyber security also, government is keen to convert the inventions into prototypes. Similarly for AI, ML and all that. Lot of platforms are available for that. Take that to the society and industrial, what we can say, the level, so that the stakeholders will get benefited. That is the real outcome of this conference. I am very much thankful to my team, Professor Sabre Madam, Bhaviskar Madam, and the and the entire team of the AI and ML department, because they are very enthusiastic, and they come with that proposal, and we collectively approved that proposal. I have faith in my team, and that's why I have taken the decision to organize this conference, and very good organization. They deserve the congratulations, the entire department and my deputy directors, deans, faculties, our management, all deserve the congratulations. It's a team event, and once again I am thankful to EAI and all of you.
Thank you, sir, for your concluding remark and your leading supervision for organizing and support for this conference. Now I would like to welcome all the research scholars to come forward and volunteer their time for the cause. Means I would like to call them for sharing their feedback about this conference. Anyone who wants to share their feedback?
Audience side.
Audience side? Yes. Yeah. Please first introduce yourself. A very good afternoon to everyone. This is Viha Jaiswal. I'm from VIP, and this is my first conference, and I found the hospitality really good. The accommodation, Bharta ma'am was very supporting for that. Initially, while I was writing the paper, even Sachi sir had helped me a lot regarding the my domain and how to do it and everything. And I found it was very good yesterday, the gala dinner, such kind of things when we actually work hard and we are appreciated. It's something very good. I felt overall my experience was like very good regarding the international conference, and yeah, also the networking. I met a lot of people, and I felt it was very beneficial for me yesterday, and that's it. I am looking forward for more collaborations. Thank you.
Thank you, dear. Anyone else who wants to share the feedback? Steering committee members, do you want to share? Core team members, yes. Yeah. Good evening, all of you. This is Dr. Monica Manga, and I have come from Vijay College of Engineering, Mumbai. I know that just to run this 2 day show, it requires planning of minimum 8 to 10 months. I know how much effort you must have put the entire department, entire management, and the entire institute. So you have run this 2 day show very, very well. I congratulate the management and the entire department which has hosted this conference so successfully. All the events, all the arrangements were very good. The hospitality was commendable. On behalf of all the members of our founding team and steering team, I congratulate and thanks all of you. Thanks once again. Thank you, Monika. Anyone else who wants to share their feedback? Okay. As we are near the conclusion of this momentous gathering, we extend our heartfelt gratitude to all the speakers, sponsors, and attendees for making this event a rounding success. I hope you all had a good time at our campus. Our best wishes to all for your bright future ahead. Now I request Professor Bhagyesh Vankar, Local Organizing Committee member of ICISML, to give the vote of thanks followed by National Anthem and group photo.
Good afternoon to one and all. I feel honored and privileged to get the opportunity to propose a vote of thanks on this auspicious occasion. On behalf of Raisoni Group of Institutions, I am thankful to Dr. Sachinandan Mohanty for his continuous guidance and support for successful organization of this conference. I would like to thank I would like to thank to all the honorable delegates, invited speakers, and participants who blessed us with their presence. Words are not enough to thank them to shape the conference. I express my gratitude towards Sri Sunil Raisoni, Chairman Raisoni Group of Institutions, and Mr. Shreyas Raisoni, Executive Director, for their constant support and blessings. I would like to extend my thanks to our Campus Director, Dr. R.D. Kharadkar, sir, for his continuous guidance, support, and motivation. Thank you, sir. I am grateful to Dr. Vaibhav Hendre and Dr. Nagnath Hulle, our Deputy Directors, and Dr. Nitin Khorde, Dean Academics, for their guidance and cooperation. I am very much thankful to all our head of departments, faculty colleagues, our HR team, our IT team, non-teaching staff members, and student coordinators who always stand by us and support us. Thank you once again. Now I request everyone to please stand up for the Indian National Anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे
All are requested to come for the group photo. All committee members, steering committee members.
Okay, ready everyone?
Yes.
Look at here. Smile. Wait.
More smile.
More smile.
Thank you.
Wait. Okay. Thank
Hello, I request everyone to take the high tea at ground floor, electrical seminar hall, room number 114. High tea is arranged at ground floor, room number 114. Everyone please enjoy the high tea. Have a good day.